Good afternoon and welcome to this new tutorial by AMIS Pro, this time focusing on advanced nesting. Advanced meaning we're going to have a look at the different options in order to come to a well-balanced nesting batch that you can actually export, trusting that it will be a successful print. So let's go for it. There's quite a few options here to go through. First, I'm going to just start by clicking nest on this specific batch here. Lots of things ready to be nested. There we are. And already one important point. Quite a few of our users think they have to wait till the 100% is reached here. Actually, most of the time that's not the case. You can press cancel. It's basically just abort after a couple of seconds, because after that, well, maybe it will keep on reiterating, but the chance that actually a much better nesting will come out is very limited. So just as soon as it reaches like 98%, you can for sure press the cancel button here. So we have our first nesting. Also, that speeds up the nesting significantly, and then it means you can start working in a different way. It's not just about click nest and wait for some minutes, 10 minutes, 20 minutes, and hope for the best to come out. No, it's more an iterative process here that you can go through. You can really change settings, change things you don't like, and re-nest and make it all go very fast, of course. So this first batch looks quite okay, but of course we have a nesting density of almost 20%. Now, not all technologies can actually work with that kind of percentage, so we should be looking into something better there. Also, when we have a look at the densities, we see here that about peaks of up to 40% for certain layers, going down here to, let's say, about 20%. So it's not what you would call a nice, equally spread build. Now, then it comes, of course, to playing with the different options that you have here. First of all, and let's start here with the default part behavior. Let's already allow all our parts to turn over the z-axis, apply to all parts, and that's okay there. Now this one is applied to all the parts, but you can still make changes to individual parts. So you can still go look into a part, and for example, this one, I will double click and say like, okay, but this one is also allowed to x-axis or something without changing that for the other parts. Right, so this will already give a bit more options, but it will not fundamentally change our packing, of course. So we haven't yet solved this problem of the 20% here. Now, one thing that people think might be a good solution here is to actually set here a nest to density. Now, this nest to density, contrary to what you might think, it does not limit the nesting density to the, in this case, given 11%. It will just stop iterating as soon as 11% has come out as a solution. Now, we can test it here, but of course, I already know in this case, the first solution that is actually found, and so it found something and it will stop immediately, is already 19.76. So it didn't limit it, it just stopped looking for alternative solutions at this 11%. So that's not really the solution that we're looking for. What we could do is that we actually increase the gap distance, of course, and that's quite an easy way, and it's also very fast, of course, to just change that, and you will see indeed that the density goes down already. And of course, in this case, not all parts will fit inside the build box anymore. But anyway, if we do have to get the nesting density down, that's just a quite logical result, of course. Okay, so now we have a 17.2% nesting density, which might still be too high, and we still are stuck here with this 36% peaks in the nesting density. So yes, the gap distance obviously has an impact, and we can keep on making it higher till 12 or 14 millimeters to reach that density. But a better way can be actually to reduce the layer density, so the density for each layer. And that's a very powerful tool, I would say. So when I click this, I can enter here a percentage that will block the density of a layer up to that percentage. As soon as it reaches that, it will make sure that nothing else is added into that specific layer. So that really keeps our density evolution very smooth. Let's try this out. Of course, here it's a bit more of an operation, so it takes a bit longer to calculate, but still, it's your usual matter of seconds rather than of minutes here. Um, Although with two programs open, it can take a little longer. Okay, there's the first result. I'm not going to wait for further results because, well, even at 79%, well, there we are. It did already find something. And then you will see that, of course, the nesting density is very smooth among this, in this case, 14% layer, with a few small exceptions going a bit over, but that shouldn't ruin the party, should it? So there we are. That's about the nesting density that we want to reach. But then on the other hand, you did notice perhaps, of course, that here the parts are packed relatively in the middle, as that's how this specific operation goes for this, or this feature works. So then there's a couple of other things you can do. You can very easily increase the gap distance, and you will get more spreading without actually changing a lot in the total number of parts that go inside, because obviously the layer density will still be the limit to look for, and not this specific gap distance. So that will nicely, and we can actually give it a try. Let's make it here 12 millimeters and go for a nesting. And that will already spread it out a bit more so that you got a more evenly layered build in there. But there's a few more tricks that will actually allow you to change that, or to navigate this, well, to make it even a nicer build, let's say. Um, let's see here, the few seconds should be over by now. Of course, we're giving it a very tough time because the with such gap distances, the options of reaching 40%, of course, also get more limited. So we're making it quite difficult on this algorithm. And maybe that's the most important lesson of this tutorial, is actually that learning to play with these different parameters will really allow you to find a nesting that is optimal for your technology on one hand, and on the other hand, going really fast so that you can go through immediately. So now here we got already a more equally spread nesting. And again, we will have this 14% limit. There's a bit more gaps here because we made it so difficult for the algorithm to find a solution. So better probably to keep this at 8. But of course, as you're gaining more experience with the algorithm and with the AMIS Pro software, you will also notice the impact of parts like this, the big bulky parts, um, which definitely, when they're not shelled, have a very high impact on the nesting density. So if we just start shelling those, and for now I won't put an extra lattice inside, we'll just keep it to the shelling, then obviously there will be quite an impact on the nesting densities, and it gives us a bit more room to play actually with these solutions. But still, the bulky parts can also in other ways, yeah, make it difficult to find a good solution for your build. Another way, of course, to deal with that, and since we're anyway having a second batch to print them, because now obviously many parts do not fit our build box, we could also choose to start dividing those parts. And you could do that, for example, by reducing, in this case we have 6 parts here. You could reduce that number by 3 and adding another 3 in the next batch, of course. Or you could choose to, and I can close this already, we have a solution. Or you could choose to, there we are, a bit more spread out here because it's more difficult, although the main difference is here, maximum is only like 5%. So Another way to go through this or to work with this is actually to move about this big bulky parts, and that's something you could always consider. If I look at this specific part, for example, and you notice that I clicked here on parts, I will just shift it up a bit so that it doesn't, like make it 150 and then lock its position, um, and this one perhaps as well. Well, let's put it up here, 150 also, or well, let's make that 130. There we are. And this one here goes to, well, maybe that one can stay. They're already a bit more shifted. So shifting those parts, those big bulky parts, will increase the possibility that you will find a nicer division of the layer densities throughout the nest. So and then we can re-nest again. But again, it's quite often the solution or part of the solution to not just nest once, but nest a couple of times, see what you like, see what you don't like, and improve the build as you go through it. And you will quickly notice that just after a couple of uses, you will start noting that, like, okay, the big bulky parts, I have to be careful there. I can maybe increase the gap distance here a bit because that will spread it out more evenly. So it's such kind of tricks that will really help you getting a very nice build very quickly. Now, with all the explanations here, took us only a couple of minutes to go through. There we are, still a few gaps here, which we could easily solve by changing here the height of one of these parts here, the big bulky parts, to have that solved. Now, all in all, again, the idea is spread your parts out, your parts out, play a bit with the different options here in the density, maybe change your gap distance in total, not forgetting, of course, that you can also change individual gap distances for bigger parts, and that will allow you in just a couple of clicks to very quickly come to a very nice spread out nesting density. Good. Good luck with that. Don't forget to call upon us if you need to. We're always ready to help out. Thanks for listening. Have a nice day.